This topic is the complex numbers. Here we have some function f of x, and we want to find f of 1 minus I. Well, this means that we have to plug 1 minus I into x. 1 minus I is my stuff. So we have 2 plus stuff, that's 1 minus I. Whoopsie. All over 2 minus stuff. And the stuff here is still 1 minus I. But this means that I have to distribute that negative to both the 1 and the negative I. Well, let's group our like terms right now. 2 plus 1 is 3, and we have the minus I. On the bottom, 2 minus 1 is 1, and we distribute the negative to the negative I to make plus I. Now, we don't want to have a complex number in our denominator, so we have to multiply the top and bottom of this fraction by the conjugate of 1 plus I. And the conjugate of 1 plus I is 1 minus I. So to keep the integrity of this fraction, I will multiply it by 1, which is 1 minus I over 1 minus I. We are using the property of a difference of squares to get rid of the I, because I squared is negative 1. 3 times 1 is 3, 3 times negative I is negative 3i, negative I times 1 is negative I, and negative I times negative I is positive I squared. Now on the bottom, 1 times 1 is 1, 1 times negative I is negative I times 1 is I, and our negative I and plus I cancel out because we had a difference of squares and we have minus I squared. Now let's keep in mind that I squared is equal to negative 1 because I is equal to the square root of negative 1. And when you square the square root just cancels out. Now let's combine our like terms. We have negative 4i, and I squared is just negative 1. That's all over 1 minus I squared, which is negative 1. Be careful about the 1 minus negative 1. That's always a bit tricky. Now let's combine some more like terms. 3 plus negative 1 is 2 minus 4i, all over 1 plus 1 is 2. And let's distribute that 2 to both the 2 and the negative 4i. So we're left with 1 minus 2i. And that is the answer. F of 1 minus I is equal to 1 minus 2i. Thank you for watching.